Okay, so we've been looking at triangles. We've done quite a lot of triangle-y stuff, and we were using our knowledge a wee bit to look at angles within circles on Thursday there. Okay, now the triangles, the majority, or where it's been important, that we've been looking at today, up to date, have been right angle triangles. Okay, so they've had one of the angles has been a right angle. Okay, so that means it's 90 degrees exactly. Okay, now there's a lot we can do with right angle triangles. These are really important triangles, and the rules that we follow for those are Pythagoras. Okay, where we've got a side opposite the 90-degree angle that's known as the hypotenuse. Okay. Now, the important thing with right angle triangles is the longest side. Okay, the longest side is always opposite that angle. Okay, and then the two short sides would refer them to. Okay, we've been touching that angle. It's created that angle. Okay, now rules for every triangle that we work with are all three angles added together are equal to 180 degrees. Standard across the board. All right. A right angle triangle has one angle that equals 90 degrees. Okay. The side opposite the 90-degree angle is always the longest side. Okay. We can use Pythagoras, the equation, which is long side squared is equal to short side squared plus the short side squared. Okay, you might have seen it before written as a squared equals b squared plus c squared, or if you've been to school more recently, c squared equals a squared plus b squared. It doesn't matter, that's why we stick to the long squared plus short equals short squared plus short squared, okay?
That's just about the
Yeah.
that's
Now, what other rule is attached to this? Okay, and this is assumed knowledge. This is assumed knowledge from that four, so we've not really touched on it. Okay, but you need to be aware of it. Okay, because they're so critical. Now, this is when we're starting to introduce this sine, cos, and tan. All right, sine, cos, and tan are ways we can use trigonometry. All right, ways we can analyze triangles. Really common sort of mathematical terms. Now the SOHCAHTOA is actually three equations. All right, and writing it out like that, okay, is a wee reminder of what those equations are. Okay, so you need to be aware and you need to know how to use these. The sine of the angle, okay, and that symbol I've done there with the circle, the line through it is just theta. Okay, that's just the Greek letter theta. So that's what I use for the angle. Sine of the angle is the opposite over hypotenuse. Okay, that's the O and the H. Cos of the angle is equal to adjacent over hypotenuse. And the tan of the angle is equal to opposite over adjacent. Okay, so this is the sort of first introduction, the first look at when we are having to actually be specific with the sides of the triangle we are using, relevant or relative, sorry, to the angle. So we need to be aware of what angle we are using, okay, and then what we are calling the opposite and what we are calling the adjacent. Okay, it's important. So once we step up into what we need to know for Nat 5, okay, that becomes really important. So let's have a wee look at an example of what I'm talking about here. If we've got a right angle triangle, and this is only works in right angle triangles, there's other rules for non-right angle triangles. So if we've got a right angle triangle, okay, indicated by that wee square, which indicates that 90-degree angle. Okay. If I've got that angle in there, and that is 30 degrees. Okay. I've got that as 10. Okay, that side there. And my missing side is hypotenuse. Okay. How can I find the hypotenuse? Find the hypotenuse. So what information I've got? Well, I've got an angle and I've got one of the sides. Okay, so if I write out, literally write out, so can I go at the top of my page and go through exactly what I've got, it will allow me to find the hypotenuse. So I'm trying to find the hypotenuse. So the hypotenuse in my SOHCAHTOA is the h's. Okay. In that case, I'm going to use either the sine or the cos equations. Okay. So that rules out the tan equation. Okay. Now, what information have I got? Well, I've got the angle. So I've got enough to work with the sine of the angle or the cos of the angle to find the hypotenuse. Okay, so I've not ruled anything out yet. What else have I got? Well, that angle in the bottom left corner, I've got the side opposite it. Okay, so I've got the side opposite. So going over, I've got the opposite side. So see that? I've got the sine of the angle, the opposite side, and I'm trying to find the hypotenuse. I've not got the adjacent. When I say the adjacent, I mean the side of the triangle that's touching the angle I've got. That isn't the hypotenuse. That's my adjacent side. I don't have that information, so I can't use that second equation. The only equation I can use to find the hypotenuse is the SOHCAHTOA equation.
So does that mean then that the 30 degrees is the sine of it or the sin of the triangle?
Plug in.
Mm.
Then I need to rearrange to work out the hypotenuse. Okay, so I'm bringing the hypotenuse. I've written the word HYP, okay, I could probably just write H in that case. Okay, if I bring H over the left hand side and sine comes over, the sine will go underneath the 10. Okay, so that would be my calculation. Now I can plug that into my calculator, whatever that may be. Okay, I'm getting 20. So the hypotenuse would be 20. Okay. So this only works, SOHCAHTOA only works when the triangle is right angled. Okay, but it's very important that we use the correct information in the correct way. So if you get given that angle in the bottom left, your opposite side is literally the side opposite it. The hypotenuse is always the longest side, and it's always opposite the 90-degree angle. The adjacent is the side that's touching the angle. That isn't a hypotenuse. Okay, let's look at that in a slightly different way. Do another example. Okay, another right angle triangle. Angle 65 degrees. Okay, the hypotenuse this time is 30, and we're looking for the opposite. Okay, the opposite side in this case is the side opposite the angle that we're getting given. So the angle's up the top right this time, the side opposite it is that one. The side adjacent to that angle is the vertical this time. Okay, so the angle that we are taking all our information relative to has changed.
Is that not hypotenuse?
The hypotenuse is a 30. So the hypotenuse is always across from the 90. She not back on this view. I'll jump it off. All right, so the hypotenuse is the 30 there. Okay, there's a right angle triangle, so a SOHCAHTOA works. Okay, I'm trying to find the opposite. I want to find the opposite. Okay, so going through that method again, always write SOHCAHTOA out fully and go through it. Well, we get given the angle. Okay, we get given the hypotenuse, so h. Okay, and we're trying to find the opposite. So we're trying to find the opposite. So that rules out that one, that rules out that one, because we've not got enough information that we can use them. So we're using sine again. Sine of the angle equal the opposite over hypotenuse, which is 30. Okay, so sine 65. Opposite of that, so we're trying to find, and hypotenuse is 30. Okay, flip that round and make the opposite on the left hand side. Okay, so that's similar to what we've done before. And then we're taking the 30 across. So that sine 65, don't get put off the fact that that sin is like a big word. Imagine that it's just a letter. Okay, it's something multiplied by 65. 65 is the angle. So when I'm taking the 30 over, it's 30 times that sine 65. Or I could write that as just 30 sin 65. Okay, that just means 30 times sin times 65. Okay, so the opposite side, putting that in the calculator, 30 sin 65 will give me an answer of 27.5. 19. Okay, I'm not putting any units in.
See when you get the sine thing, it opens the bracket, doesn't it? To put the
Yep,
number.
that's fine, yep. Just close that bracket. Okay. What I want you to take away is the importance of understanding the angle that you're using. And then what becomes relevant is where the opposite is and where the adjacent is. The hypotenuse is always going to be opposite to 90. And the hypotenuse is always going to be the longest side, okay, in a right angle triangle. Okay, that's my hypotenuse. And the angle will select this one. Okay. I want to find the hypotenuse. Okay. So right angle triangle, the top and lower. Okay. What have we got this time? Well, for the angle. Okay. We're looking for the hypotenuse. But this time, we've not got the opposite. So the opposite side is this one. So we've not got anything there. No info there. Alright. What we've got is this 40. That is the 40, which is the side that's touching the angle that isn't the hypotenuse. That's the adjacent side. So I've not got the opposite this time, I've got the adjacent. So I've got enough information to use the cos. That's the adjacent side over hypotenuse. Again, I'm looking for the hypotenuse this time. Cos 40 is equal to adjacent, which is 40 over hypotenuse, what we're looking for. Okay, rearranging that, and bringing h over to the other side. And then I'm bringing cos 40, and remember that's just cos multiplied by 40, that's coming across, leave, isolate h. And I just put that in my calculator.
Daniel, see my answer in the calculator, it's always like,
Okay, so remember this is just relevant for right angle triangles. Okay. Not got enough information for that, not enough.
Wait a second, it's 40 cos 40.
40 divided by cos 40.
This is just pen back and got something to do it.
It's just using different aspects of it. So we're using the angles this time. So that a squared, or the long side squared equals short side squared, or short side squared. You need two sides, and then you can find the other one.
What's another night there was the short side, I was identifying the fact that I cost it was the short side one side, but I wasn't doing the cost of,
So
it was just basic.
this is knowledge that you need to have.
Yeah.
It will be unlikely to come up.
Ah.
So, but what I wanted to use it for is because you need this knowledge in respect of using trig. You can only use this when it comes to right angle triangle.
So that's not normal, why is it then after what it was something that's in a position? No. Because that's I actually think I was planning.
Okay, well, Melissa's away getting help. let's have a wee look at using the tan option. And then we'll find a couple of angles, and then we'll forget all about it and move on. All right, so right angle, opposite side of that is your hypotenuse, longest side, blah, blah, blah. All right, let's have this angle in here, and let's say that is 59 degrees. Why not? Okay, let's have this angle, this side here, and I want to find the opposite. Okay. So if I go again, so my three equations that I can use to find my unknowns. Okay, the unknown this time is my opposite. The opposite side is the opposite side relative to the angle that we have. So that one. Okay, and we get given the adjacent side. Okay. What do we have? We've got the angle, so we'll tick off S, C, and T. We can use all of them so far. What are we looking for? Well, we're looking for the opposite. And what do we have? Well, we don't have the hypotenuse. Okay, so that rules that one out. We don't want to use that because we can't find the opposite. And we do have the adjacent, so we can use the tan. Okay, so tan, the angle is equal to the opposite over adjacent. Okay. Tan of 59 is equal to the opposite over adjacent, which is 12. Remember that adjacent is the side that's touching the angle that isn't the hypotenuse. Okay, so we're looking to find the opposite, so switch the equation around so it's on the right side. Then move the 12, and it becomes 12 times tan 59. Your opposite side. Okay, I'll put OP so it doesn't, you don't think it's 0. Okay, the opposite is 12 tan 59, which I'm getting 19.97.
See if it doesn't come up with this, it might come up within something more.
Yeah, so they say you need to know it, but it's assumed you know it from National 4. So you learn this in National 4 level. So it's one of those things that you may have to use it in one of the questions, okay? But it's not necessarily taught formally on that 5, and you'll see why in a minute. Good thing it's not 2023 now. You know, see the 2023 paper, it was really hard. It was almost a reaction to the last couple of years when it was released. So they made 2022.
How close that was?
It's weird.
It's horrendous.
So see, it's
The first year
in 2022.
no, 2023.
2023.
That
Yeah.
was the first year I started, or the year I was, I couldn't actually learn it. It was like, speed this to question, that question,
Hey, that's
sorry to make it negative, but just,
quite being negative. This is all about positivity.
I'm just trying to get positive, like, just trying to put this year will be easy, because that was hard last year.
I wouldn't. I mean, let's hope so.
Oh,
There might be
that's-
a- there might be a- There might be a reaction with it trying to balance it.
Oh, God, I'll put with the positive, I know that.
I mean, aye, definitely.
I think the maths department in my school put a complaint in about the exam. It's terrible because so many people failed it in my school.
Okay, so looking at that information there, okay, we're now missing an angle, so we're getting asked to find the angle. Find the angle theta, alright, so just a Greek letter, okay. Look at what. Okay, this time we're trying to find the angles. Alright, so let's just highlight that, that's the one we're trying to find. Okay, now what have we got? Well, we've got the side, the angle that we're trying to find, we've got the side that's opposite that. Okay, so you can even mark that up, opposite. Alright, so we've got the opposite. Got the opposite. Okay, what else do we have? Well, we've got the side that touches the angle, but isn't the hypotenuse. All right, it's a smaller side than the hypotenuse. The hypotenuse is always opposite the 90, so that's the adjacent side. Okay, so what have we got? We've got the adjacent, we've got the adjacent. So we've not got enough information to use the so. We've not got enough information to use the car. What we need to use is the tan again. All right, so tan of the angle is equal to opposite over adjacent. Okay, so you can write that off, adjacent. Okay, putting in the information we know, don't know the angle, we've got the opposite, which is 15, and we've got the adjacent, which is 20. Now, when we move over the tan, or sine or cos even, okay, how we do that in a calculator is important to know. Okay, but what we leave when we move it over is the angle. Okay, we're just going to be left with a number to represent that angle. Okay, how you write it when we move the tan over, is tan to -1, and then in a bracket, take a 15 over 20. Now, what that tan to the -1 represents is essentially 1 over tan, but we don't write it for whatever reason. Okay, be like 1 over tan like that. So the -1 comes from the fact that it's the bottom of a fraction. Okay, but you don't write it like that. So that's because the tan and the angle, the tan is times the angle here. So it's tan times the angle. So when we're moving it across, it should really become a divide. But we don't write it as 1 over tan. 15 divided by 20, write it tan to -1, 15 over 20. Okay, and that's how you see it in your calculator. Okay, so have a look at your calculator at the tan button. If you press shift and then the tan button, you'll get tan to the -1 in your calculator. Okay, and then you're just putting in the 15 divided by 20. And you're getting an angle 36.9 degrees. Okay, so it's really important there that the opposite and adjacent are right way around. You're using it in the correct way. Okay, so it's all about the angle that you're using. You don't necessarily always have the same sides represented by the same letters or the same names in this case, opposite and adjacent. Okay, I'll do one more for you. All right, then we'll move on. Right angle. Okay. Okay. Have we go at that? see what equation you're using. All right. Have a look at what you've got and see what equation you're using. Okay, we can rule out cos and we can rule out tan. So we're using the sine in this instance. Sine of the angle opposite over hypotenuse. Sine of the angle opposite is 20, hypotenuse is 50. Okay, angle, we can write this side of -1, 20 over 50. Shift sine 20 divided by 50. What I'm going to do, separate question that looks very similar. Yeah. Find the angle. What's that?
Oh, it's in there.
I don't know anything about this. I implied it was right angled, right? Okay, just to finish this off then. Then you've got an example of every type. Okay, so write it out. We're looking for the angle. Like that. Okay. What have we got? Well, we've not got the opposite, but we've got the hypotenuse. Okay, and we've got the side that touches the angle that isn't the hypotenuse. Okay, so there's two sides touching that angle. So we've got the adjacent. So we're using cos. Work 7.2.
Was there any inspiration done last year? Do I not form?
They're not. So it's not as you need, just in case. It would be part of a bigger question. And I'll show you what there'll be past paper questions, so it's relevant. I'll show you. All right, so remember what we've been doing for the first hour. Well, spent a lot of time fixing my microphone. Let's say first half hour, is we've been looking at right angle triangles. Okay, so triangles with a right angle in them. Now, unfortunately, not all triangles are right angles. Come in all shapes and sizes. Okay. Non-right angled triangles. Have three angles. Three sides. Oh, this is going to be really hard to try. All right. But none of those sides, or sorry, none of those angles are 90 degrees. All right, it's as simple as that. So you might have angles smaller than 90 degrees, acute angles, you might have angles larger than 90 degrees, which are obtuse, okay, but you have no 90-degree angles in it. Okay, so we're looking now at non-right angle. Okay, there's a bunch of different ones that can come up. Now, these also have rules. Now, these rules are given to you in the exam. It's just about application of them. All right. Okay, so in the front cover or the first couple of pages in your exam paper, you'll get given a formula sheet. Okay, so some of our volumes, for instance, were on that formula sheet, so we've seen it before. Okay, what else is on them is something called the sine rule. Okay, which is a over sine A equals b over sine b equals c over sine c. Small case in capitals is deliberate, okay? We've also got something called the cosine rule, which is written in two different ways, but it is the same thing. It's just been rearranged. Okay, so they give you it in two different formats. Okay, they give you it in the format a squared equals b squared plus c squared minus 2bc cos a, which looks horrible, but remember you get given it. Okay, or they also write it as cos A is equal to b squared plus c squared minus a squared over 2bc. Okay, so you get given them in your exam, we just need to know how to apply them. Okay, now when you're looking at these, really importantly, lowercase letters refer to the length of the sides. Okay, lowercase will be the length of the side, so that will be millimeters, centimeters, meters, potentially kilometers. All right, so that will be a distance. In the capital letters, refer to the angles. Okay. Units is always degrees. Question that always comes up is, why is that spelled with a C? And why is that cosine? Why is that sine? Why is there extra letters involved? Literally, sine and cosine is just a shortened version of that. Alright, it's sine, cosine. Tan is shortened for tangent as well. Okay, so don't worry about that. Alright. Just shortened it all the time. Okay, so look all right. Could have spent all that time drawing that triangle, no use. Anyway, move on. Actually, what?
Sometimes you draw lines inside. No.
Potentially. And inside.
Trying to make
There might be a past paper question where I think I know what you're asking, but it's not necessary to draw lines inside, per se. There's a past paper question where you've got a non-right angle triangle, but you then end up drawing a line inside it to make a right angle. Don't confuse yourself. Right, non-right angle triangle, okay. What have we got? Well, we need to name our angles and our sides using our letters, okay, that make up the rules, okay. Now, it doesn't matter as long as you're consistent. So, the angle you pick for the letter A, the opposite side to that will be your side A. Okay. Angle you pick for your letter B, opposite side, be your side B. And so your large letter and your small letter are linked. So capital A is the angle opposite side A. Likewise for C, likewise for B. Okay, so the A squared equals B squared plus C squared minus 2BC plus A. Okay, those letters have to refer back to side A cos A. Okay. Let's do a question. Non-right angle triangle. Okay, we get given side, we get given an angle. We get given a side and we get asked to find unknown angle. Now, I get that question presented to me in the exam. I've got two sides and I've got two angles. What I first need to identify is whether it's a right angle or a non-right angle. Now it's a non-right angle, there's no right angles involved there, so it's non-right angle, so I'm going to be using sine or cosine rules. Now you need to sort of look at the information you've got and work out what rule applies to how you figure that out. Okay, so we're trying to find a missing angle here, so let's look at the rules that we've got. So if I write out the sine rule again, I've got A over sine A, and B over sine B, and C over sine C. Now, I told you right at the start that it doesn't matter which angle you call A, and which side you call A, as long as the angle you pick is connected to the opposite side. So A and sine A, I'm going to call this angle here. That's going to be my A, therefore that's going to be my side A. Okay, so I'm going to put that in my equation. 10 over sine 35. So I've got everything there that I could solve that and get a number for it. What else have I been given? Well, this is my unknown. This is what I want to find out. So I'm going to call this one B. All right. And what's opposite B? Do I have that information? That's my side B. Okay. So my side B is 18. My sine B is my unknown, but that's okay. I'm wanting to find out an unknown. So let's just leave that there. Now, there's three parts of this equation, and that's important because I can find multiple things. So my C over sine C is still connected to this triangle, but I've got none of the information. So my angle C is up there, and my side C is down here. I've not got any part of that. Okay, it's still hanging about. But what I can do now is I can rule that out. I don't need it anymore. It's irrelevant. I don't need it to be part of the equation. I don't need it to solve. I'm just going to rule that out completely and just focus on the two parts of the equation that I need. Okay? So you don't have to keep hold of all three parts. You're going to have to rule one of these parts out. In this case, we've ruled out that C. You can literally just rub it out. You're only ever going to use two parts of this equation to find one unknown. In this case, we're trying to find sine B. Now, sine B, oops, oh no.
How would you know it's about zero?
Because we're not got any information. Or not rule it out. But,
Yes,
so I'm ruling it out,
yeah, but how we can roll it, is that what to roll it?
because we have no information for it. So, there's no numbers for either that angle or that side, so there's nothing we can find out, there's nothing we can rule out there.
Is that labelled as A and B then?
No, you need to do that. So you need to pick the letters that go to the, it might actually be labelled something completely different, it might be labelled P, Q, R. Alright, but you need to know how to use this formula, manipulate it, and ignore this PQR and call it ABC. Angle A related to side A. Angle B, side B, angle C, side C. Okay, so rearranging that. Okay, just going to move to the side a wee bit. Rearranging that, sine B I'm going to bring to the top line. Now that's important, it's on the wrong side, but I can bring over to the top line and I'd have 10, and it would be written sine B over sine 35. Alright, looks a wee bit weird, but this fits. Okay, now I'm going to isolate the letter B here. So remember, that sin is just something I'm using in the calculator. It's just a button in my calculator. It's something I'm multiplying by the letter B. So B is a number. Alright, so that's sin I can move over. So that's sine 35 in the bottom of that fraction I can move over. So I'm going to move that first. Ten. Okay. And then I'm going to isolate B by moving the sine over. I'm going to move it over a wee bit. I'm going to isolate B by moving the sine across. And when I move just the sine, it becomes sine to the negative 1 and 18. That all goes in bracket. And that will give me the angle that I'm looking for. All right. Shift sine 18. Right, sorry. Make that side 15, not 18. I've made it too big relative to the other side, so that angle doesn't work. Make that 15. All right, so that will flow all the way through. Make that 15 instead of 18. All right, now it should work now. Okay, so sine 15, sine 15. Okay, should be 60 degrees. Nothing. Okay, so changing that 18 to 15. Now there's a lot going on there, so I've written out quite a bit. Okay, essentially it's just the labelling and the numbering of the sides. I got 66. Okay, so using the sine rule, just slightly differently that time. Math error. Make sure you're closing your brackets if you're getting a math error. All right, so 12 sine, and then in brackets it would be 38. Okay, and then divided by sine 46, and the 46 would be in a bracket. One tonight, okay, but if you want to try it over the next few days, that's fine. So, cosine rule. All we're on there. Okay, we use that. Find the missing side. Okay. So that A is our unknown side. So it gives you, essentially, it gives you one of your labels. So it won't label it, this is side A, it won't signpost it in such an obvious way, but A will be the unknown. Okay, A will be the unknown. So, using the cosine rule. Draw a triangle. Not in blue, pass through it blue. Okay, so this is question 1A on page 9 of your booklet. Okay, question 1A, page 9 of your booklet. What you're given is an angle, 38 degrees. You're missing side X, and you're given this side and that side. Okay, so you're given one angle, you're given two sides, and you're given a missing side as well. Okay, so how do we label this? This side is going to be our A. This is our unknown. That means this angle is going to be angle A because it's opposite. Okay, so when we're using the cosine rule, it's really important that we identify A, side A and angle A, because side A is our unknown and angle A is being used in the equation. B and C, it doesn't actually matter which order it comes in, so don't worry about too much about that. That can be B. And that can be c. Alright, doesn't matter. Either way. Okay, so a squared equals b squared plus c squared minus 2bc plus a. Nice and long. B, we've said is 5 plus c 3 minus 2 times 5 times 3 times cos 38. Lovely bit of equations. Put that in a calculator. And spit out an answer. 5 squared plus a squared minus 2 times 5 times 3 times cos 38. I'm getting 10.4. Okay, then A is the root of that. In whatever units it is, it's centimeters. Okay, so it's actually maybe easier than the sine rule because it's giving you so much information, you're trying to pack it all in. Okay, what's the time? 26. Let's call it a night there. Any questions, give me a wee shout.